This is a pretty good time to briefly look at a related dynamic in how variables are assigned in Python. There are some variable assignments that function similarly to how those function calls work. So observe this with integers. In this code on line 1, we create a variable called myInt1 and give it the value of 5. And then on line 2, we create a new variable called myInt2 and assign it to the value of myInt1. The value of myInt1 was 5, and so it would seem that now the value of myInt2 should also be 5. Then on line 3, we reassign myInt1 to equal 7. So the question here is, does myInt2 now equal 5 or 7? Did we assign myInt2 only to the current value of myInt1? Or does myInt2 follow myInt1 around and copy its value whenever it changes? In other words, did we tell myInt2 you now equal the current value of myInt1? Or did we tell myInt2 you should always equal myInt1? We can check and see. On line 5, we print myInt1, and as expected, its value is 7. And on line 6, we print myInt2, and its value is 5. So myInt2 was set equal to the current value of myInt1. But if the value of myInt1 changed, myInt2 didn't change. What happens when we try that with a list, though? We saw before that integers and strings seem to behave similarly, but lists behaved differently. So let's check out what happens with a list. On line 1, we create a list called mylist1 and set it equal to the list of 3 strings, 1, 2, and 3. On line 2, we set mylist2 equal to mylist1. And on line 3, we make a change to mylist1. Did this change, did adding this value then affect mylist2? We can print them and find out. Sure enough, mylist1 has the extra value, the 4, but perhaps surprisingly, so does mylist2. They both have that extra value, which means when we called mylist1.append4, we were calling that on mylist2 as well. So to go back to our same analogy, when using integers, it's as if there's a file somewhere that has a number on it. And when you need that number, you go and you copy that number down. If Addison then comes along and changes that number, then you still have the old number. myInt2 didn't keep up with changes to myInt1. However, with lists, it's different. It's like you and Addison are looking at the same piece of paper at the same time. If one of you makes a change to it, then the other will immediately see that change. You're sharing the same piece of paper. You're not copying it to your own. Now that might sound strange since the paper has 2 different names, but that's similar to how you and Addison could just have 2 different ways of locating that file. You might call it file number 58712, and he might call it the file it's 3 back in the drawer in David's office. He doesn't know my name for it, I don't know his name for it, and yet we're still looking at the same file. So the names like mylist2 and mylist1 are just that. They're ways of finding the underlying data. And you can have more than one way to the same data. Now, to make that analogy even simpler, you likely refer to your mother as Mom, while others simply refer to her by her name, in my case, Margaret. Those are 2 different identifiers that point to the same underlying quote-unquote data. Saying Margaret is my mom means that anything that happens to Margaret happens to my mom. 2 different names for the same person. Just like here, we have 2 different names for the same data. So once again, there are 2 important takeaways here. One is just that. We can refer to the same data by different names. We can have multiple variables that point to the same data, and if you access and modify the data via one variable name, it also modifies the data for any other variable names that point to the same data. That's a subtle but fundamental change in the way we've thought about variables in the past. We've thought about them as very close ties between a variable name and a value, but in reality, a variable name is just a way of finding the value. And second, as with our function calls, we see that integers and lists behave differently. An integer will not keep its data up to date if the variable to which it is set changes. But that's not the case for a list. Again, this comes down to mutability, which we'll talk about next.